In this next problem, our goal is to find the zeros of the polynomial. The problem gives us a hint that one of the zeros is negative 5i. Unfortunately, this is an imaginary number, so it's going to make the problem a little bit harder. We should probably space out the coefficients of our polynomial, since now we're going to have real and imaginary parts of our problem. It's still going to work out the same way, but it takes a little bit longer since we're working with imaginary numbers. Although, since they give us one imaginary solution, we should know what another imaginary solution is for free. By the conjugate zeros theorem, we should get a positive 5i as a second solution to this problem. Since this is an x cubed problem, that means we're only going to have one more solution to find after we find the two imaginary solutions. So we're going to do this just like we did before. Our 1 carries down. Then a negative 5 times 1 is a negative 5i here. Notice that these are not like terms, so we're going to have to keep them separate, like so. Then I take my negative 5i and multiply times that whole term there, but we're really distributing, so when I do this, I've got to multiply both of those pieces times the negative 5i. I'm going to do the i's together first. Negative 5i times the negative 5i is a positive 25i squared, and negative 5i times a 3 is a negative 15i. Why did I write the 25i squared beneath the 25? Well, that's because if we recall, I squared is negative 1. That means the 25 and the 25i squared are going to have like terms. And in fact, 25 and a 25i squared, those are just the same but opposite. So those cancel each other out. And then I've got my negative 15i, which I'm going to take that times that, will give me a positive 75i squared. So 75i squared is negative 75, plus a 75 gives us a remainder of 0. This is good news because the hint was in fact actually a 0. That is, x equals negative 5i is a 0, or x plus 5i is a factor. Because it worked, we're also going to try positive 5i. And then we're going to use the depressed equation. 1, 3 minus 5i minus 15i. This looks bad, but it won't be bad. So 1 carries down. 1 times 5i is a positive 5i. Combining like terms gives us 3. 3 times 5i is positive 15i, which is exactly opposite that. So our remainder is 0. What does that mean? That means x equals 5i is a 0, or x minus 5i is a factor. Well, what's left with our equation? What's left is 1x plus 3. 1x plus 3 is already linear, so that's a factor, which means x equals negative 3 is a 0. So depending on what this question was asking, if it asked us to factor completely, then our problem is now factored. X plus 3, x minus 5i, x plus 5i, is it factored? If it asks for the zeros, then the zeros are -3, 5i, and -5i.